So, welcome you all to this video lecture regarding the of course computer architecture. So, session 7. So, here we are going to discuss about regarding to this of RISC and CISC. So, reduced instruction set computer and complex instruction set computer. So, here this RISC is actually it is a processor architecture that actually uses a what a small set of simple and fixed length of instructions in this part. Actually, this processor normally a processor will perform what all arithmetics and logical operations such as and or not those logical operations inside where the processing unit registers or in a processing unit or in a control unit. So where these operations not only happens over in that of CPU registers such as also it has been happen over in the accessing memory with respect to the instructions such as load and store. So which means that the load and store instructions in the next slide we can able to see this load and store instructions. Actually this will execute the most instruction in a single clock signal. So RISC will perform this all this of complete instruction over to a single clock signals. So using with respect to the hardwired control. So the one clock cycle signal for each instruction it will happens to get clear over with using what hardwire control. So with respect to this hardwire control, the all the things has been get executed or in the reduced instruction set computer. So which will helps us the futures which means as added efficienting of adding features such as with respect to this RISC processor we can able to get fasten it easier to the top pipelining architectures where the power efficiencies and ideal for modern applications is with respect to the smartphones, embedded systems and IoT devices. So these are the things is will get involved over in this reduced instruction set computer. So before to that I have said two instructions as which means that it will handle with respect to the top what the load and what store instruction. So here we can able to see this load and store instruction. So this RISC will get implemented with respect to this load and store instruction. So this load and store instruction will help to perform within of one clock cycle signal. So the thing which we need to get keep in that of our memory that the load and store will helps of communicating between that of main memory and a CPU. So this thing has been mentioned over in this RISC processor. So reduced instruction set computer. So here these are the some of the characteristics of this RISC architecture. So the first things has been mentioned over to the relatively few instructions. So here this relatively few instructions is of load and store. So followingly relative of few addressing modes such as here the addressing modes has been mentioned over with respect to this RISC processor or register addressing mode, immediate addressing mode and base addressing modes. So these are the three addressing modes has been involved over in this RISC architecture. So the next thing with respect to that of a memory access limit to that of load and store, here this load and store instruction will be communicated with where the memory. So arithmetic and logical instruction can never access the memory directly. So the next thing is the all operations are performed within the CPU register, which means after loading the data into the register, all calculations has been performed inside the CPU register. So automatically the register will much faster than the memory, which means this will improve the processor performances also. So the next thing is the fixed length, which means the fixed length instruction format. So all these RISC instruction have the same instruction length, which means that all the RISC processor has the same fixed instruction length. So each instruction may occupy of around of 32 bits. So 32 bits of things has been occupied over here in this fixed length, and these 32 bit can be easily get decoded into the rough instruction format. So the next thing is single cycle instruction. So single cycle instruction already I have mentioned that one clock cycle signal. So most of these RISC instructions completed within of a one clock signal. So simple instruction will require or will access the less processing time. This efficiently improves the processor speed. The next is the hardware rather than of a microprogrammed control. It is so automatically we can able to say that is a hardware control unit. So this RISC processor will uses this hardware control instead of microprogrammed control. So this hardware control will generate or it will produces the control signal directly from where the hardware circuits is. So simply we can say this instruction set automatically becomes faster with respect to the hardware control. So the processor design is also will be get simpler in order to get of complex things as. So real-time example we can able to say with respect to the RISC is switching on a fan automatically using the wall switch is immediate. So reading a manual before switching on the fan would take longer time. So this hardware control works like a wall switches. As a short glimpse, we can able to say this load and store instruction will get communicate between of a memory and CPU. So all automatic logic operations will be performed where inside of a CPU register. So the memory can be automatically accessed only at the beginning and at the end of the program. So in the middle over to the top it doesn't get accessing the memory. So the thing here we are going to with respect to the of example x is equal to a plus b into c plus d. So here here these are the what the RISC program. So first initial thing is done here, the load the value of a from where memory to a register. So next is the load the value of b into the register R2. So the next thing is load the value of c into the register R3. So next says load the value of d into the register R4. So automatically we are going to get see that R1 equal to a, R2 equal to b, and R3 equal to c, and R2 equal to 4. So then we have mentioned the instruction add R1 comma R1. So automatically it will do the performance of adding a plus b. So it will gives us it automatically store the result in where R1 register. So the next thing add R3 so it will gives us the thing c plus d. So here this automatically stores the results in the register of R3. So now we are going to do the multiplying of R1 R3. So automatically it will do the functionality of R1 has carries the a plus b, and the things is next is c into c plus d. So finally we are going to add these, which means that x equal to this thing we are going to store in the register of R1. So next is the store x comma R1. So finally we are going to copy the final results from the register of R1 and we are going to move to the location x. So this is the thing. So here we can able to see the three major things has been get involved, such as load, register, and store. So this is what we are going to we have saw in that of RISC. So these are the some of the advantages and disadvantages. Advantages carries the faster execution, easier pipelining, better compiling optimization, reducing the hardware complexity, low power consumptions. So automatically we can able to give a simple day-to-life example, which means that RIFE processor are widely used in where means smartphones, tablets, IoT devices, and embedded systems. So disadvantages also there. So some of the disadvantages such as the more instructions for complex operation, which means that we need to mention more number of information instructions for a complex operation. So the code sizes will automatically become large, which means a larger program size. So and it requires the efficient compiler. So these are the things which have been get involved in the RISC processor. The next is a CISC, so complex instruction set computer. So now we can see the differentiation between the RISC and CISC. Automatically we can see the CISC operations from that also. So with respect to the parameters such as instruction set, instruction length, and the number of instruction execution time, memory access, design complexity, and power consumption, performance pipelining complexity, and design psychology, with respect to these parameters, which means that futures we are going to compare this RISC and CISC. So first we see that with respect to the instruction set, we have the large number of instruction set get carry over in the CISC processor, while in the RISC has simple and smaller instruction. So length, while we see in the RISC has a fixed length of around of 32 something bits has been mentioned in the top RISC. So here we have in the CISC processor as a variable length. So number of instructions also get many instructions as with respect to the 100, whereas in the RISC we have some few instructions around of 100 or less. The execution time, this is also compared with respect of RISC. The CISC has some instructions may take multiple cycles, whereas in the RISC we have the one clock signal. So one clock signals has been taken in the RISC, whereas here the multiple clock signals. So next, with respect to the memory access, here the CISC has a complex instruction in order to get accessing the main memory. So it will take us of multiple times. So the next is the load and store instruction, which means that accessing that memory, we are going to give the instruction namely as a load and store. Automatically then it will do the process of loading and storing the accessing memory. So with respect to the design complexity parameter, the CISC has a more complex hardware design, while in the CISC has a simple complex design. So simple hardware design. So example with respect to that, we can differentiate it with respect to this RISC and CISC, such as for RISC example, we can able to see this ARM processor, MISC Spark, whereas here CISC has the example, real-time example such as Intel x86 and VAX. So with respect to the power consumption, CISC will consume higher power while comparing to that of RISC. It will consume of low power only. Pipelining, it is difficult to implementations due to the instructions complexity, while here this RISC is easier and is efficient for pipelining things. So complexity also, it will be more complex in hardwares with more number of initialization of transistor, while in the RISC has a simpler hardware and fewer transistors has been installed it over there. So performance, with respect to the performance, CISC will automatically emphasizes the powerful instruction that need to be get work or need to be get involved over to do the per instructions, while in the RISC we need emphasizes the things is speed is the main things, is will do this simplicity and pipelining. So thank you.